consider the circuit shown below. Find V1, I2, and I3. So V1 is the voltage of this battery here. And then I2 is this current here, and I3 is this current here. So that are what we are looking for. And I think I will use the Kirchhoff current law or the Kirchhoff junction rule here at point A here. Let's write that. Let's do the Kirchhoff current rule or junction rule. And we do it at A. And the Kirchhoff junction rule said that the sum of the current that goes in will equal to the sum of the current that goes out. What is the current that goes in? We have this one here, I1, and also I2, which is both goes to point A, right? So we will have I1 plus I2. Here, I1 plus I2, and that will equal to I3. However, we know the value of I1, so let's plug that in. So I have 2 plus I2 is equal to I3, or maybe let's move this 2 to the right hand side. So we will have I2 is equal to I3 minus 2. Okay, and nothing further that we can do from here. Let's save this as equation number 1. Okay. Now, aside from junction rule, we can also do the Kirchhoff loop rule. Here in this circuit, we have 2 loops, right? So we'll have loop 1 here. And this one here, the second one, is loop number 2. However, I want to label all the resistor. So here in R1, we have the current is I1 here, and the direction is going up, right? So eventually it will turn and get into this current. And then for the polarity, where the current comes from is the positive side, and where the current goes to is the negative side. This will be very helpful later. And then here we also have R2, and the current that pass through it is I2 going up. And again, I label the polarity here. Where the current comes from is positive terminal, and where the current goes to is the negative terminal. Okay, and then this I3 will goes here, and eventually it will flows across this resistor. So I will have I3. And then we will have positive sign here and negative sign here as before. Okay, now let's do the Kirchhoff loop rule at loop 1. Okay, Kirchhoff loop rule at loop number 1. And the Kirchhoff loop rule said that the sum of the voltage in a loop will equal to 0. And that is why we label all the resistor polarity. Okay, so now let's start with this loop 1 here. And here, the current, the loop here, entering this V1 from the negative terminal. So I will have minus sign. And then the voltage here is V1, right? V1. And then plus, we will have R1. R1 is 12 ohm, and the loop entering from the positive terminal. So I will have plus, yeah, and then we'll have 12 ohm. And then the current that pass through it is I1. So I will multiply this 12 by I1 because of the Ohm's law, right? So voltage is equal to current times resistance. This 12 is the resistance and I1 is the current, right? And then we move on to this last component in this loop. And here we have to be careful because the loop here entering from negative terminal. So we will have negative sign. And then we will have 6 ohm here. Good. And then the current that pass through this resistor is this I2. So we will have I2 here. And all of that will equal to 0. Okay. Now what can we do from here? We know I1, right? So let's calculate that. So I have minus V1 and then plus 12 multiplied by 2 ampere, right? I1 is 2, and then minus 6 of I2, and that will equal to 0. And so we will have V1 and then plus 6 I2 is equal to 12 times 2, that will be 24. And again, I think nothing that we can do from here, or maybe we can do something here. Let's plug this I2 into this equation. So we will have V1 here, and then plus 6 multiplied by I3 minus 2. And that will equal to 24. And then we will have V1 plus 6I3 minus 12. That will equal to 24. So we will have V1 here plus 6I3. That will equal to 36. And I think we can save this here as equation number 2. Now let's do another loop rule, but this time at loop 2. However, we need to clean this up first. Okay, now let's do it at loop 2. At loop 2. And again, we have the sum of the voltage is equal to 0. Let's start from this battery here, and then it enters from negative terminal. So we will have negative sign. And then the voltage here is 21. Good. And then the loop here entering from the positive terminal. So I will have plus sign. And we will have 5 ohm multiplied by I3. And then for the last component, the loop here entering from the positive terminal. So we'll have plus here. And then we will have plus 6 multiplied by the current that passed through it, which is I2. Good. Now what can we do? This all is equal to 0. Okay, now let's plug in that I2 is equal to I3 minus 2. So we will have minus 21 plus 5I3 plus 6, and then multiplied by I3 minus 2. All of that will equal to 0. Now we will have, okay, let's move this 21 to the right hand side. So we will have 5I3 plus 6I3 minus 12. And then this will equal to 21. So we will have 11 I3, and that will equal to 33. So we will have I3 here. What is I3? I3 is 33 divided by 11. So I will have I3 is 3 ampere. And we have one of the most important values, right? I3 is equal to 3 ampere here. And we found our first answer. And then what can we do from here? Let's plug this into another equation. So we will have I2, right, from here. So here we will have I2 is equal to I3 minus 2, but I3 is 3 ampere. So I'll have 3 minus 2. Therefore, we have I2 is equal to 1 ampere. And this is the second thing that we are looking for, which is I2. This is the answer for this question here. So now we just need to find out V1, but that is quite easy because we know I3 here. Okay, so we have from equation 2, V1 plus 6I3, but I3 is 3, so I'll have 6 multiplied by 3. That will equal to 36. And then we will have V1 plus 18 is equal to 36. We can subtract 18 to both sides. So we will have V1 is equal to 18. And the unit here will be in volt. And this is also the last thing that we need to find out. So this is P1 here, which is 18 volt. And I think we have found all the answer. P1 is 18 volt, I2 is 1 ampere, and I3 is 3 ampere. It is very satisfying because they are all integers. Okay, I think that's all for this problem. Thank you for watching and see you in the next video. Bye bye.